Welcome back, everyone, for another deep dive. We often get questions about black holes, and
It's a fascinating subject.
it really is. And this time we're going beyond the usual, what happens when you fall in, spaghettification, all that. We're tackling a really big question today, and I love it when you guys send these in. Are we actually living in a black hole?
It's a mind-bending concept, and one that surprisingly has some scientific merit.
Exactly. And we're going to unpack it all today with, of course, the work of physicist Poplawski. Now, we've got a ton of your YouTube videos, articles, even some forum threads, all wanting to understand Poplawski's theory.
It's a theory that really challenges our fundamental understanding of the universe, particularly the Big Bang.
Right, because if someone was taught, the usual Big Bang theory back in school, this might seem completely out there.
Absolutely.
So maybe we should back up a bit. For those who might not be familiar, what are we talking about when we say Big Bang, and what are some of its, shortcomings?
Okay, so the Big Bang model is essentially the prevailing theory for how our universe began. It suggests that about 13.8 billion years ago, the universe started from an extremely hot, dense state and then expanded rapidly outward.
Like an explosion, basically.
Kind of, yeah. And this expansion is still going on today, which we can observe through things like redshift.
Right, galaxies moving apart like dots on an expanding balloon.
Exactly. And then there's the cosmic microwave background radiation, which is like this faint afterglow of the Big Bang.
Okay, so we have evidence that supports it, but you're saying there are holes in the Big Bang theory, so to speak.
Well, it doesn't explain everything. For example, it doesn't tell us what caused that initial expansion, what was there before the Big Bang, or even what exists outside the boundaries of our universe, if there are any.
It's like asking what came before the beginning, right?
Yeah.
And that's where Poplawski's ideas come into play.
Exactly. He sees black holes not just as these cosmic vacuum cleaners, but potentially as, well, as you put it, cosmic nurseries.
I like that. But, okay, before we get too deep into the weeds, we should probably define what a black hole is. I mean, we all have a vague idea, but...
Right. So a black hole is essentially a region in space-time where gravity is so strong that nothing, not even light, can escape from it. They form when massive stars collapse at the end of their lives.
So all that matter gets squeezed into a tiny point.
Exactly, a point of infinite density called a singularity. And surrounding this singularity is the event horizon, the point of no return. Once you cross it, there is no coming back.
There are different types of black holes too, right?
That's right. You have stellar mass black holes, which are formed from the collapse of a single star, and then you have supermassive black holes, which are millions or even billions of times the mass of our sun.
And those supermassive ones are the ones usually found at the centers of galaxies, like Sagittarius A, right? That's the big one in our own Milky Way.
Exactly.
So hypothetically speaking, if we hopped into our spaceship and took a little trip toward Sagittarius A, what would we experience?
Well, for starters, it would be a very long trip. Sagittarius A is about 26,000 light years away from Earth.
Okay, so assuming we had, like, a really fast spaceship, something that could, bend the rules of physics a bit, what happens as we get closer to this black hole?
Well, as you approach a black hole, the first thing you'd notice is the warping of space-time.
Time travel.
In a way, yes. Time would actually slow down for you relative to someone on Earth. This is called time dilation, one of the strange consequences of Einstein's theory of relativity.
Okay, so time gets wonky. What else?
You'd also experience extreme gravitational forces. The closer you get to the black hole, the stronger these forces become.
And this is where things start to get a little messy, like with that whole spaghettification idea.
Yeah, spaghettification is a rather dramatic, if not entirely accurate way to describe what happens. Basically, the gravitational pull on your feet would be so much stronger than on your head that you'd get stretched out like, well, spaghetti.
Okay, so maybe not a fun trip. But this is where Poplawski's theory takes a hard left turn from the usual story, right? Tell me more about this torsion idea.
Right, and this is where it gets interesting. Yeah, so torsion is, well, it's a pretty complex concept in physics, but in simple terms, you can think of it as a kind of twisting force.
Okay.
And Poplawski's theory suggests that this torsion force could become really significant in extreme gravitational environments, like, at the heart of a black hole.
So instead of everything just collapsing into, like, an infinitely small point, this torsion.
It provides an outward push, counteracting the inward pull of gravity.
So it's like a cosmic bounce. Instead of a big bang, we get a big bounce.
Exactly. That's Poplawski's idea. He calls it the big bounce. The matter collapses under gravity, but instead of hitting a singularity and ending there, Torsion takes over and causes a massive outward expansion. A whole new universe is born.
Whoa. So you're saying our universe, everything we know, could have been born out of a black hole in a previous universe.
That's the theory. And it gets even wilder. If our universe exists inside a black hole, then who's to say there aren't black holes within our universe that are also birthing new universes?
Okay, now my head is starting to spin a little bit. So like an infinite loop of universes inside of other universes.
It's called a multiverse, and it's a mind-boggling concept.
Mind-boggling is right. But let's bring this back to something a little closer to home. We talked about Sagittarius A earlier, the supermassive black hole at the center of our galaxy.
Right.
Poplawski actually suggests that our universe could have been born inside something like Sagittarius A, right?
Yes, he believes that the conditions inside supermassive black holes like Sagittarius A would be, ripe for a big bounce to occur.
But wait, if we're inside a black hole, why aren't we being crushed by gravity? I mean, shouldn't we feel it?
Well, the thing is, gravity acts on a curve. Imagine like a bowling ball on a trampoline. That bowling ball is our black hole, and the trampoline is space-time. The bowling ball warps the trampoline, creating a dip, right? But we're like tiny ants living on the surface of that trampoline. We experience gravity as we always have because we're moving along the curve of that warped space-time, not falling directly towards the center.
Okay, I think I get it. But let's say Poplawski is right. What are the implications of all of this? If we're living in a black hole, a universe created by a black hole, what does it mean for us?
Well, on a day-to-day basis, probably not much, at least not immediately. We'd still go to work, worry about the weather, all that.
So you're saying even if we are living in a black hole, cat videos on the internet will stay just as important?
Exactly. But on a grander scale, it completely changes our understanding of, well, everything. It suggests that our universe isn't alone, that it's part of something much, much bigger.
A cosmic family reunion. But seriously, where do we even begin to look for evidence of this? I mean, it's not like we can just hop in a spaceship and fly into a black hole to take measurements.
True. Direct observation isn't really feasible right now, but that doesn't mean there aren't clues out there. Poplawski himself has suggested that we could look for echoes of the Big Bounce embedded in the fabric of our universe.
Echoes like leftover sound waves from the Big Bounce.
Not exactly sound waves, but something similar. Think about the cosmic microwave background radiation we discussed earlier, that faint afterglow of the Big Bang.
Okay, yeah.
Poplawski believes that the patterns in this radiation, particularly something called polarization, could actually hold evidence of the torsion force at work during those very first moments of our universe.
Polarization, that's like the direction the light waves are vibrating, right?
Yeah, exactly. And then there are gravitational waves, which are ripples in space-time caused by, incredibly energetic events like the collision of black holes.
Right, we've talked about those before on the show. They're like these tiny tremors in space-time that we can detect.
Exactly. And these gravitational waves could carry information about the events that created them, potentially even offering us a glimpse into, the heart of a black hole or the conditions during a big bounce.
So by studying these cosmic whispers, both gravitational waves and the cosmic microwave background, we could potentially find evidence to prove or disprove Poplawski's theory.
Exactly. It's a bit like trying to piece together the history of, say, a lost civilization from just a handful of artifacts.
It's a long shot, but potentially a huge payoff if we find something.
Absolutely. And that's what makes this kind of research so exciting.
It's amazing to think that we started this deep dive talking about black holes as these, monstrous things that pull everything in and destroy it. And now we're considering the possibility that they might actually be creating entire universes.
It really speaks to the constantly evolving nature of our understanding of the universe. There's always something new to discover.
Right. And it makes you wonder if our universe really is just one of many, maybe even an infinite number of universes, all connected somehow through black holes. I mean, what does that even mean for us? How do we even wrap our heads around that?
It's a huge question, and I'm not sure if there's even a simple answer. I mean, practically speaking, we can't really interact with these other universes, at least not yet, so maybe it doesn't change our everyday lives all that much.
Yeah, the cat videos will keep on coming no matter how many universes are out there.
Exactly. But in terms of our place in the cosmos, it really makes you question what we know, It suggests that there's so much more to reality than we can currently observe or even imagine.
It's humbling, isn't it? This idea that everything we know, everything we've ever experienced, might just be this tiny, tiny fraction of what's actually out there.
Absolutely. But it's also incredibly exciting. It pushes us to keep asking questions, to keep searching for answers, even if those answers lead us to even bigger questions.
Yeah.
Like, where do we even go from here? What happens when we realize that our understanding of the universe might be, well, just the tip of the iceberg?
I think it just makes the search for knowledge even more important. We have to keep exploring, keep theorizing, keep looking for those little clues that might unlock even bigger secrets of the universe.
Because even if some of these ideas seem, you know, a little out there, a little far-fetched, sometimes that's where the most groundbreaking discoveries come from, right?
Absolutely. Remember, a lot of what we understand about the universe today was once considered crazy, impossible, even laughable. But the people who made those discoveries, they didn't let that stop them from asking questions and pushing the boundaries of what we thought we knew.
And who knows, maybe someday we'll look back at this conversation, at Poplawski's theory, and it'll be just another accepted fact in textbooks. Or, maybe it'll be something even wilder that we haven't even thought of yet.
That's the beauty of science, isn't it? There's always something new to uncover, always another mystery waiting to be solved.
You've given us a lot to think about today, so to you and to everyone listening, thanks for joining us on another deep dive. Keep those questions coming, and we'll keep searching for answers, no matter how mind-blowing they might be.